It moved more earth in a single day than an entire army of workers could shift in a month. And it did it using nothing but steam, steel, and operator skill. The Baccaris 95T steam shovel became the defining machine of the Panama Canal construction. Built by the Baccaris Company of South Milwaukee, Wisconsin. Deployed by American engineers after France's catastrophic failed attempt left the jungle reclaiming everything. Each machine weighed approximately 95 tons. Its dipper stick could scoop 5 cubic yards of rock and earth in a single bite. Operating continuously across multiple shifts, one shovel could remove thousands of tons daily. At peak construction, over 100 steam shovels operated simultaneously in the Culebra Cut alone. The sound was described by workers as permanent thunder echoing through the valley. The Culebra Cut required removing over 100 million cubic yards of material. Steam shovels made it possible. Without them, the canal simply doesn't exist. And perhaps the most remarkable detail, operators became so skilled they could place a dipper load into a rail car with surgical precision at full operating speed. The machine that moved a continent one bite at a time. It could unload an entire train of excavated rock and dirt in under 4 minutes. Without it, the steam shovels would have buried themselves in their own output. The Lidgerwood rail crane was the critical logistics solution that kept Panama Canal construction moving at impossible speed. Built by the Lidgerwood Manufacturing Company of New York, designed specifically to solve the removal bottleneck that was strangling excavation progress. Steam shovels could dig faster than conventional unloading methods could clear material away. Trains backed up. Shovels stopped. Progress halted. The Lidgerwood eliminated that problem entirely. Its cable system ran the entire length of a loaded train simultaneously. Multiple cars unloaded in one continuous sweeping motion. Material flew off flat cars and landed precisely in designated spoil areas without manual labor. The system operated on the same rail network serving the excavation front. Trains loaded at the dig site, moved to disposal areas, unloaded via Lidgerwood cranes, and returned empty within a single coordinated cycle. At peak operation, over 160 trains per day ran through the Culebra Cut alone. The Lidgerwood system processed every single one. Chief Engineer George Goethals called it the most important auxiliary machine on the entire project. And perhaps the most striking detail, the entire unloading crew for one train consisted of just 2 operators, 2 men, 1 machine, 160 trains daily. They ran 24 hours a day, 7 days a week, through tropical heat, monsoon rain, and landslides that buried entire sections of track overnight. And they never stopped long enough to matter. The Baldwin steam locomotives were the circulatory system of the Panama Canal construction. Built by Baldwin Locomotive Works of Philadelphia, the most prolific locomotive manufacturer in American history. Over 4,000 individual locomotives eventually served the canal project in various configurations. Each locomotive hauled flat cars loaded with excavated rock, concrete, equipment, and supplies between work fronts stretching across the entire isthmus. The rail network at peak construction covered over 160 kilometers of track, constantly expanded and relocated as excavation progressed. Track crews relayed entire sections of railway weekly. As the Culebra Cut deepened, tracks descended with it. Locomotives operated on grades that would challenge modern equipment. Landslides were the constant enemy. Millions of tons of unstable hillside collapsed onto active track without warning. Recovery crews and Baldwin locomotives cleared debris and restored operations within hours. At peak construction, trains departed the Culebra Cut every 4 minutes around the clock. The logistics operation rivaled any military campaign in complexity. One Baldwin locomotive logged over 400,000 kilometers of service during canal construction alone. And perhaps the most powerful detail, the rail network built for canal construction became the foundation of Panama's national railway system. The machines that built the canal, then built the country. They worked underwater, in complete darkness, removing rock and sediment from a canal bottom they could never see. And they never stopped for 4 consecutive years. The canal dredges were the invisible workhorses of the Panama Canal project, operating simultaneously in the Atlantic and Pacific approaches while steam shovels dominated headlines inland. Without dredges, ships could never actually enter the finished canal. The Corozal and Paraiso were among the most powerful dredges ever built at that time. Each carried massive cutter heads that rotated continuously against the underwater rock face, breaking material loose for suction removal through pipes stretching hundreds of meters. Dredge crews lived aboard their vessels continuously during operational periods. No commute, No shore leave during critical phases. The machines and their operators became single permanent units. Combined dredging operations removed over 30 million cubic yards of underwater material from canal approaches alone, material that no land-based equipment could ever reach. Sediment from tidal movement required continuous maintenance dredging even after construction completion. The carousel remained operational for decades after the canal opened in 1914, and perhaps the most remarkable detail, dredge operators navigated exclusively by feel and instrument readings. They never once saw what they were removing. Blind machines building the world's most important waterway. They stretched steel cables across valleys wider than city blocks and moved concrete buckets weighing several tons through open air with pinpoint precision. No crane in existence could do what they did. The giant cableway systems were engineered specifically for Panama Canal lock construction. No existing equipment could efficiently deliver concrete to the massive lock structures rising simultaneously at Gatun, Pedro Miguel, and Miraflores. Standard cranes couldn't reach. Conventional transport couldn't keep pace. Each cableway system stretched between two massive steel towers anchored on opposite sides of the construction zone. Cables spanning up to 800 feet carried buckets holding 4 cubic yards of fresh concrete per load. Operators controlled cable tension, trolley position, and bucket release from elevated control stations with direct sight lines across the entire pore area. Precision mattered enormously. Misplaced concrete in lock construction meant structural weakness that could catastrophically fail under ship traffic decades later. Multiple cableway systems operated simultaneously above each lock site, and perhaps the most impressive detail, the cable towers themselves required no permanent foundations. They relocated as construction progressed. Moving machines building permanent structures, engineering contradiction at its finest. Wilday, they poured enough concrete to build an entire modern city. Every cubic yard mixed on site, delivered on schedule, placed with precision in structures designed to last centuries. The concrete mixing and crane systems of the Panama Canal locks represented the largest continuous concrete construction operation in human history at that point. Nothing remotely comparable had ever been attempted before. Each mixing plant combined crushed rock, sand, cement, and water in precise ratios determined by engineers who understood that lock walls would bear forces no previous concrete structure had ever experienced. Ships, water pressure, tidal forces, decades of continuous operation. Mobile cable cranes complemented the fixed cableway systems, reaching areas where permanent installations couldn't operate efficiently. Together they maintained concrete delivery rates that kept lock construction advancing on schedule, despite tropical conditions that accelerated cement setting times dangerously. Workers developed precise choreography between mixing crews, transport operators, and placement teams. Fresh concrete had limited working time in Panama's heat. Coordination failures meant wasted material and structural compromises. Quality control was unprecedented for the era. Concrete samples were tested continuously. Substandard batches were rejected entirely regardless of schedule pressure. The finished lock walls at Gatun reach 81 feet thick at their base. Over a century of continuous ship traffic has produced zero structural failures, and perhaps the most extraordinary detail. Engineers deliberately overbuilt every lock structure by significant safety margins. They expected the canal to outlast their calculations entirely. They were right. It's still running perfectly,